Okay, hey everyone. This is going to be the third live stream today. If you follow with the last two, first one we covered the basics of entity modeling and the basics of meta prompting. Last week's stream, we started going into more detail into meta prompt engineering, and we decided that we're going to be doing this by additionally building up a solution for lesson plan generation, personalized lesson plan generation. So we started on this solution last week and built up a kind of basic frame for what a prompt like this would look like. And then today's stream, we're going to be focused on building this out into an actual meta prompt engine. And I'm going to be tying a bunch of stuff together to show you how to do this, particular modularization, emergent tool workflows, and long context. There's a lot of different ways that we can realize solutions like this now, and it'll be kind of fun. So we'll go through the whole process. Before we go into the prompting stuff particularly, though, I wanted to cover a few things. In particular, I want to cover each week. I want to go over some news and talk about some things that have happened since the last week briefly, just so we can get an idea and cover some more stuff in these streams. Okay, I think it'll be useful. Anyways, for Patreon subscribers, I added a little bonus to where you'll have access to this page. I'll be updating this page with new research as it comes out from this point forward. And if you open these up, you'll see it's a really good way. It has the original text here and also has a distill, taxonomy, and a tensor formalization, which allows the LLM to reason more deeply with the information, and visualization to help you visualize any kind of processes or workflows presented in the research paper. Okay, bunch of different stuff here. You can feed these into LLMs to interface with the information on a deeper level, and it's also just easier to follow with the different research. So if you're on the Patreon, feel free to leverage this and see my latest post for access to this link. Okay, but on this note, I want to actually talk about some of this research here because there's a lot of stuff happening right now that I think is really important to understand the implications of. Okay, so for one, a big one was this transformer fam paper released, right? The focus of this paper was basically adding in a feedback loop. It would result in almost an emergent form of working memory by having it attend its own internal representations in latent space, okay? And the point of it doing this would be that it would be able to process infinitely long sequences of tokens, okay? So this is very similar to what Google's been trying to do. They added the compressive memory mechanic to the transformer, and it resulted directly in massively improved context lengths. The significance of Google's method is that they're streaming the entire input through, so the model is able to progressively learn from the input, even with massive inputs, right? So any kind of mechanism on the transformer architecture itself that allows it to work on its own representations automatically and inherently is going to directly result in increasingly better ability to handle infinitely long sequences, which directly translates to long horizon tasking, okay? And also means massively improved learning in general. So we're headed in a direction where infinite context is a reality. Maybe not infinite yet, but extremely large is very doable. I think the next round of LLMs we see is going to be leveraging a lot of these techniques all together, and it's going to be really crazy what it can do. In general, the memory is just so important because memory is directly related to learning, right? Now, for a while, I was saying that you really need the embedding models to do this, right? But Google has shown that there's other ways to pull this off with just integrating new advancements into the architecture model, right? By adding compressive memory like they did, it's able to come extremely close to the type of learning possible with embedding models, which is extremely impressive. Okay. This is another thing. This is another paper that was done by DeepMind. So just something I want to keep in mind here is that I know a lot of people downplay Google because of how behind they are in comparison to OpenAI time-wise for releasing things, right? But Google has a lot of experience still with creating agents, right, and agentic workflows, right? So they have a lot of people that are skilled with this stuff, and I would expect to see a lot of agent development coming from Google into the near future. They just needed some time to catch up to GPTs, okay? but Google's been doing some research on these simulated agents, agents that operate in simulated environments, right, from natural language instructions. And it's really, really, really cool, because basically what we're finding out is that with these models, right, you really just need a good framework and an engine that can properly convert natural language to actionable to actions, right, for different environments. And there's a lot of things that you can already do. This isn't going to impact this immediately, but what this is going to do is that this is going to directly result in, maybe about a year from now, some really crazy video games and controllable agents across different environments. I think this is the end game of this, because in reality, like the game theory with getting this stuff to work in games, it's very similar to how we can get this to work in different domains and all kinds of stuff. So there's a lot of simultaneous effects from trying to push this in 3D environments, in particular game environments, right? And you can see that with Sora, what happens when you start integrating physics engines into the model as well. Okay, so this is something that's going to be a big deal in maybe not near future, but semi-near future. Okay, this is a big one that I didn't see a lot of people talk about, probably because they don't realize the way that this pairs together with everything else. But many shot in context learning. This is Google studying what I'm doing with their model right now, just to be completely honest with you. I've been I've been pushing this to some crazy limits for a while now with many shot and context learning. Okay, and the reality is that with their new architecture, with the compressive memory in combination with this, absolutely insane. It has completely changed my mind on prompting in terms of like what in terms of what solutions will look like and like how things will work into the future, in a good way, right? It's opened up so many doors to this being a thing, right? Basically what this means, like a shot is input output, right? A shot is a training example, right? So what this says and what this is basically explaining is how you can train new behavior and unlock emergent functionality by using many shot in context learning, right? Basically preventing a bunch of training examples for something on top of other things really, really, really works. And there's a whole, and like this is a whole direction of its own that's just being explored right now. There's a lot of significance to this, right? But basically, this is something that I'm leveraging hardcore right now, and something that is basically necessary to fully leverage 1.5. Shots don't necessarily have to be input outputs. You can think of this shot in this case as like how this is really working as just a module, right? It could be a module of anything, and then you can build out a network of modules synergized, right? And that is your prompt, right? And then you can work from that solution space from this master prompt. Okay, these can be massive, like these can be like 1 million tokens if you want, right? But you aren't going to really see 1 million token data sets for this stuff that are actually properly curated, right? I'm typically doing about 200K tokens right now, because past that I would just be adding stuff that isn't properly curated. But anyways, you can set up many shot ICL environments for different things. I've already shown you kind of how to do this in the basic level for different things, right? But for entity modeling, it's a great example of this, because once you finish a knowledge graph or a model of anything, right, you can convert it into a many shot ICL format and then use that as a master prompt to then work out of a new, way more advanced solution space. Okay. It's just this is the end result of so many things getting tied together and coming together into a type of solution. So this is just a heads up for me. This is definitely where prompting is moving towards in terms of these master prompt systems. Okay, because they're just crazy good, and nothing. You don't really. I need to specify that, and this doesn't really mess with anyone's work, right? What this means is that you can take your work and turn it into grander scale forms and systems, and then it'll work like this, right? So basically, like this is what I was talking about with like refining task prompts and stuff like that. If you've been refining task prompts in a certain manner, following similar understandings, right? Those task prompts can then be generalized and turned into an engine that can replicate how you were kind of doing that for different types of tasks, right? That would be one module of one of these kind of systems, right? And then in one of those modules, you could have shots in that module that actually functionalize how that particular module works, right? And then you can build that out to increasing degrees. Okay. But basically, this is extremely important. It was missed by almost everyone, but this is me letting you know as a pro tip. This is the most important thing that's been released in a while. Okay. Because this is directly what's happening. Other things that we can talk about briefly were some of the advancements in video and speech models, right? The craziest one was VASA 1. I think this was Microsoft that did this. Basically, they have a way to take a picture and like it was like 5 or 10 seconds of audio. I can't remember what the exact amount was. And it can convert it into a realistic talking head. Right? It's actually pretty crazy. If you haven't seen the videos, let's just go to the paper. All right, so audio clip in a single image. And the thing that they did here, which I like, is where do they say that? They de-entangled. It's not here, but it's in their paper. Disentangled face, light and space construction, right? They have disentangled certain aspects of modeling facial expressions and stuff like that, right? For this framework, and it has really resulted in a much better and more realistic depiction of talking heads, right? To learn to same space, I would really recommend once you start reading this stuff, I would recommend, like, this is kind of how I like to interface with these research papers, right? First, I'll distill them, right? And look through the distilled information. And then once I'm primed on the information, I then go through and understand the mechanics to a finer detail, right? Once you start doing this, you'll start to see a lot of similarities and a lot of stuff, right? You see a lot of similarities in words and approaches and how this stuff is trying to be done, right? The difference here is that this is just different models, different AI architectures, right? Different desired outcomes, right? This is working with video models, with generative models. Okay, so this is really cool. I don't know, as amazing as AI is, it's like the face and the image and video stuff is the cause of a lot of concerns here, because this stuff has the potential for a lot of abuse in comparison to text, right? I mostly focus on text and what can be done with text. So video and sound isn't my specialty in that sense, but it's something just as important, and it's going to have a lot of impacts. So it's just that we're going to see a lot of gatekeeping with this tech in comparison to text. Like this is going to be used for surveillance, and there's just a lot of bad stuff this stuff can be used for. But it's also a lot of cool stuff they can be used for too. It's just going to cause a lot of problems and solutions at the same time. Yeah, it's going to make a ton of money. Absolutely. It's inevitable. Yeah, they didn't even use that much train data either. It's just a really efficient way. It's a really efficient architecture for this, right? The framework they have here is really solid. And I think you can see that with their examples here. I was really impressed. Normally I'm skeptical of this stuff, but I was actually genuinely really impressed by what they did with this. I'm glad they're not releasing it yet. We'll put it that way. Okay. So this was another one. I don't need to talk about this one too much. These really aren't that important either. These are more opinion pieces on stuff. Actually, no. This one was a research paper. They did a experiment with people in Kenya. They gave access to this advanced what was it called? They gave it, I can't remember what it was. Yeah, they gave people access to a GPT-4 powered business mentor to see how it affected their performance, right? And they found that it had very varied performance for the employees, right? Some positive outcomes for high performing employees and negative outcomes for lower performing employees. And the thing that I find interesting about this is, let me find where it was. It was the analysis of why that was happening, which was really interesting to me. It's because they found that the lower performing employees were selecting more complex. We're trying to have the LLM perform more complex tasks in comparison to the higher performing employees. Let me find where it actually went over this in detail. I can't remember right now. Either way, I find it very interesting that that's the case, right? So I think as I think about it more, I think it has to do with a lot of with progressive complexity, right? I think the people that are getting good results from LLMs are people that understand how to leverage this in terms of like, you can't give it an extremely complex task just like that and expect it to do something properly, right? There's a lot of intermediate steps between step A and step B usually that we use ourselves for reasoning, right? And it's the same way for LLMs, right? When you try to go from step A to step B with no intermediate steps, you're not going to get a lot of good results, especially with LLMs, right? I think people that are more focused and methodical with how they're leveraging LLMs are going to be getting a lot more usage and benefits from this compared to just expecting it to do everything for you, right? Obviously, this is a very nuanced subject, and this is only one of the very first studies that's been done. This is not a lot more studying to be done. However, you can kind of see similarities to this study with some of the things that are happening in our countries, right? And how people are using this stuff, right? People are using this stuff in different ways to different levels of success. And I think it's important to analyze that to understand why that is. Okay. This was an opinion piece by I think it was Mark Levin. Yeah. Michael Levin. He's very, very similar to what we talk about in the Discord, right? How there's an emergence of a lot of different types of intelligence happening right now, and we need to be very open-minded about the future because there's a lot of shit that's going to happen. He takes us to another level with talking about this takes it more of a humanistic approach in terms of the potential future, but it's hard to deny the truth to what he says in terms of how things are shaping up, right? It's pretty crazy future we're headed towards. Okay, this is something to keep in mind here is that yeah, we already knew this with the right setups. AI is able to pretty much do anything. I just want to talk about how our benchmarks that we use nowadays are completely obsolete. Like, we do not actually have good benchmarks that test this stuff in complex ways. Our benchmarks are extremely basic compared to what we as humans are able to actually do. The test questions and stuff that we use right now are not good examples. So it's like AI surpasses human performance. Yes, because our performance benchmarks are pretty crappy and are completely outdated at this point. We need completely new standards and testing frameworks for understanding actual intelligence, because right now what we have just does not even remotely come close. So right now, based on our current metrics, yes, we already knew this though, and it's only going to increase like that because this is computation tied to natural language, right? So tied to our knowledge, so it makes sense. Okay, so that's the news, right? Important aspects here is the move to architectures with longer context windows, memory, all that kind of stuff. I fully expect to see moves from OpenAI at some point to address these, because they need way longer context windows. They need way longer input windows. They need way longer response lengths, or else they will absolutely fall behind. And they also need memory, which they are in the process of adding at some point. We just don't know when. So that's the news recap for past week. If you want to stay up to date on that, the link's in the Patreon. Okay. All right. Let me look through the comments real quick. Yep, this stuff is gonna make a lot of money in general. Absolutely. I don't know. Like, I honestly think that OpenAI got blindsided by Google's advancement with the long context the way they did, because they didn't announce it. until it was done, right? They announced it and released the model like very shortly after. I don't know. I mean, OpenAI has the ability to handle much longer context sizes, and I've already known that for a while. When you start working with emergent tool behavior, you can get extremely long responses. These responses are generating thousands of tokens, right? That's the problem, right? That's why originally I was so like, why did they remove this? Because this was allowing so much work to get done. They massively nerfed the amount of tokens that were available. I don't think they actually have anything close to what Gemini's able to do with 1 million plus. I don't think they have that architecture, right? So I don't know. It'll be interesting to see if they were training GPT-4 in a manner that is not compatible with these advancements. Any other thing, I'm not sure. We'll have to see. They really need to make a move on that though, for sure. Like we're gonna get agents and memory and instruction blocks in OpenAI or in ChatGPT. I would say within at max. This is me making max a month or two, right? There's no way it's more than that. But then the question will be, if they don't add in better context windows, like will it even be worth it to use it then? Because I mean, the smaller response lengths just cripple everything. You can see it with Discord bots, right? The lack of response length cripples its usage, right? I can't stress enough how important response lengths and input lengths are for everything, right? The more you shrink that, the less you can do, and the more difficult it makes everything to do, right? Yeah, well, we'll have to see. I mean, if they do memory properly, and if you can actually edit the memory, that's the thing here. I don't know if they'll actually let you edit the memory. I think you can, from the pictures I've seen, you can delete lines of memory it has, but I don't know if you can actually go in and add ones of your own. They mentioned that you can talk to the model to have it update the memory dynamically based on whatever you say, but we'll have to see that in action. I don't know. There's a lot of talk. I'm trying not to believe much of I'm not trying to like follow a lot of OpenAI says they have or does until they release something at this point, because they've been hyping stuff for way too long. They need to actually release something, right? It's just that they had like when they first released GPTs, everyone who signed in like that first hour, like you got the pop-up for the memory block and all that kind of stuff, right? Some people even had access to it then. So we already know it's functional and has been functional for a while. We just don't know why they're not releasing anything, right? That's the main thing. So there's many things that they have done, and we know they have done. It's just a matter of when are they going to push that button to put it to the public, okay? All right, so now let me swap camera. Let's start focusing on the main content of the stream. Okay. I want to revisit briefly what we were doing. Right, the idea here was to create personalized training plans, lesson plans for a particular person on a particular domain that they can follow and learn and work with, basically to learn a new subject or skill or something in a really high quality tailored fashion, right? Leveraging the power of LLMs to do this, right? So in order to do this, you have to have a generalized engine for a lot of different parameters. You have to have something that can work for different domains in different topics, different subjects. It needs to be able to be personalized dynamically based on the individual person and the different factors that go into defining their current knowledge and what they're trying to do with their learning goals, right? And then it needs to actually create the content, and then it needs to plan the content first, right? And then all of this stuff comes together into a single entity, right? So this is actually, it seems simple, right? And if you narrow it down from the start to a particular thing, like if I hard code in food industry from the very start, this greatly narrows the solution space and streamlines setting up a solution for it, right? But that's no fun, because we can do this on a grander scale and do it for everything at the same time, right? It's just a little bit more complex, but at the same time, this is the direction things are moving with the modularization. So it's good to set things up like this anyway, because you can continually generalize it to new things, okay? So the idea here is to build a meta prompt engine that can complete, this is the goal, comprehensive lesson plan generation from a given input and parameters, right? So this is not the actual meta prompt engine. This is the desired outcome, comprehensive lesson plan generation, right? Now the engine to do this is going to be a little different from this, right? Because this helps guide this prompt I made that was advanced upon the one here. Where is it? All right, this was their prompt. Okay, this was their prompt. All right, I kind of advanced it a lot. All right, but this is how they had it set up, right? So they have some basic instructions and they have parameters defined in the prompt already, right? They have hard coded 60-minute class session. They only actually have 2 parameters selectable for the template, right? You can pick your grade and you can pick your topic, and then it creates this. Like this is what they had set up, right? This is not a good prompt at all, right? This, where is it? This is not a good. Okay, this is a better prompt, but this in itself is not the solution to this problem, right? Because this solution is grander than just generating comprehensive lesson plans, right? You need a grander solution to actually do this properly, right? This is just a task prompt, right? This is a good task prompt, but it's not the system, right? So let's look at what we were doing. All right. So where we ended was that we tested out these couple different sections, layer by layer, right? And when I ended, I modularized this into a couple different layers, okay? We have the high-level framing at the top here, okay? We have an input template here, and we have a response template here, okay? What we were doing while we were ideating this prompt was we were forming the initial primary logic behind selecting the core nodes of dynamically, right? What we're trying to do here is we're trying to basically create an engine that could perform meta sequence optimization on a set of atomic reasoning nodes based on abstracted parameters to complete a task in the best possible way, right? So here's the thing about lesson course generation is that there's a ton of precursor steps that need to be done in order to actually generate good lesson plans, right? Because there's a lot of synthesis steps that need to be completed in order to do this part properly, right? There's no real way to actually do this in a single input output, right? Because not only that, but you actually have to generate the lesson plans, right? So the generating the lesson plans is going to take up responses of its own. So this stuff has to be set up beforehand. And this needs to be modularized to a further degree because this is too narrow. This is really only a single module of what the solution would be. This would be framing the initial node selection for what the course would be, right? So what we're going to do today is I'm going to build this out into an actual meta prompt, right? And this is just going to be a single layer of the meta prompt, all right? So we're going to modularize this and build it out and do this properly, bottom up, okay? Starting from this base and working way up, okay? So that's the plan. And now we're going to be ideating what this architecture is going to look like on Excalibur real quick first. Here, let me get my drink real quick and then we'll get started. Give me 1 minute. All right, let's get started here. So if you have the, I want real quick, make sure that I'm sure everyone here is, but if you're watching this from YouTube or something like that, make sure that you are aware of the live stream link to Notion. I have a page built for this. Here you can see I have the link on the Discord, and I'll have it attached to the video as well. But you can follow along with things here. I'll be keeping this updated as we go along. Okay. Anyways, I've already kind of ideated a little bit of how the modules might go. So if you want to look here, you can get an idea for what we're going to be doing here. Okay. Let's see. All right. So this is going to seem a little complex at first, but this will make more and more sense as we go. All right. So our goal here is what? Our goal is to create a engine that can dynamically generate personalized lesson plans and any domain. And so in order to actually do this, what does the LM need to have, and what are the steps that need to be completed in order to actually be able to do this, right? We're going to be defining this in a generalized manner in order to functionalize this, okay? So in order to actually make a good lesson plan for something, what is a requirement from the very, very start, right? You need to have you need to have domain knowledge, right? You need to have a good model of the domain or the subdomain that you're trying to create lesson plans for, right? It's a really key thing here. So depending on the domain and the subdomain and the quality of knowledge that the LM already has on that, the first step can take a couple different forms, right? At first, we're not going to focus too much on building out the domain knowledge acquisition module, but then we'll come back later and expand that out, right? But for the first part is defining and curating the domain knowledge somehow, right? So first module is going to be something about formulating right. Ideally, you want to start from some kind of structured knowledge. Okay. Ideally, you don't necessarily have to, but it's ideal. So once you have this knowledge, right? Now, once you have this knowledge modeled, what's the next part? Now the LLM needs to be able to understand what the user wants, the particular parameters of the learning preferences the user has, their learning goals, all that kind of stuff. Now the LLM needs to know the particular details of what the user is looking for, right? And this can happen separately from the domain knowledge acquisition, right? So this step is going to be learning objectives and percentages. Okay, so now the LLM has expert knowledge on a domain, and it understands it's been downscaled based on the particular parameters that the user has established, right? It understands at this point what the user is trying to do. Okay. Now it needs to actually plan the course. Okay. You can generate a single lesson, right? That's not going to be very good because unless you're trying, I mean, I can't think of a, maybe you guys can think of one, but I can't think of a single domain that can be covered in a single lesson, right? Like if something can be covered in a single lesson, it's probably not something that you need to use an LLM to learn in the first place, right? Most of these things are going to be complex, right? And they're going to need to be broken down over multiple lessons. Okay, so the important thing here is now that you have the domain knowledge and the parameters, now you need to structure all of this in a coherent manner. Okay, and to do that, This is what I call the atomic node selection and meta sequence optimization, right? This can be formally called, oh, what am I doing? This can be formally called, oops, lesson plan structure and sequencing model. Oh, I fucked that up. Right. The goal of this one is to create the course structure of the course. Okay, maybe we should change this course structure. All right, so this one is going to be what we were just doing in the previous live stream with, where is it, with this prompt. Okay, this was trying to refine out this module of the prompt. Okay, actually creating the core nodes for lesson plan generation. Okay, and then once this is done, once this is the plan. Okay, once the plan for the lesson plan generation is done, right, you have a checkpoint at this point, right? Because the end result of this is a structured course of nodes, right? So after this part, now you can add in the generation module, right? Which would be lesson. Right now, this module will synthesize each lesson based on the established course structure, the learning objectives, and the domain knowledge. Okay, so this structure was tailored based on the domain knowledge and the user preferences, right? The lesson content generated will be tailored through multiple things, right? It will be tailored through the expert knowledge, scaled through the parameters the user selected, through the structured and organized course. Okay. When you put this together, you're able to get some extremely good lessons done in a dynamic manner, right? And now remember, for this particular solution, right? I've already done this, right? I've already set up an engine for this, which is what let me create those prompt engineering courses that I've been sharing, right? I did this process for that. It just was not, I just did not modularize it like I'm doing in the stream, because I didn't have the time, right? This takes a little bit more time to set up, properly modularize, but when you do that, you can actually leverage this to way further degrees, okay? So I already know this works, right? The challenge, which is the challenge with any of this stuff, is turning this into a generalized setup that can work in different environments dynamically and will work consistently, right? So I'm going to go ahead and tell you right now, the problem with this particular solution is that this is very, very, very difficult to pull off in GPT because of the response length limits, right? You can set up solutions for this in GPT. It's just that it'll be a lot more complicated to do and will probably require a lot of tool sequences to pull it off, because the 8K character limit is such a killer in terms of applications, right? Ideally, you want to have an SPR, right? Establish parameters from your user, have a module to create the course structure, and then actually generate the stuff. This is going to probably be, if I had to guess, it's going to be way more. It's going to be way more than 8K tokens, right? You can pull out. Here's the thing with GPT, you can do this part pretty good. This part and this part you can do well. This part is extremely crippled by its response length limits. Really only, you really want 8K. You want 8K token output in order to be able to do this part properly. This part is tricky too with GPT because you're extremely limited by what you can actually imbue with domain knowledge. Most of these solutions kind of require just going off of its base knowledge, just because trying to inject some kind of representation without screwing up things, because if it's a small context window, it's doable. It's just more tedious than it needs to be. Okay, so here's the thing. We're going to set this up as much as we can in GPT with the setup we kind of already have established. And then once we start hitting the limits, we can start moving this out. Okay. But a lot of this is you can set anything up in GPT. You can build these modules and you can do right now GPT is like the weak link. Like if you can get something to work in GPT, you can get it to work in everything else, right? So I like to work when I'm building stuff like this, I like to work in an environment that is as static as possible, and eliminates as many extraneous values or factors as possible, right? And right now GPT is a good environment for this because with this particular setup, right? Again, I can control system prompt, right? And the dialogue is completely controllable. So it's really flexible with using it. We can do something similar and we'll swap to Google Studio when once we start hitting the limits here. But it's still a good platform to set some stuff up on because they have the GPT platform already, right? Okay. So this is a dynamic module, and I'm going to be keeping this dynamically intentionally because there's multiple ways. You don't necessarily have to have an injection of domain knowledge. Like for most things, you're going to be able to get away without this. Okay, this is going to be something that gets built out to improve the quality of this as we go. Okay, but the main core functionality is this part, right? And kind of how we'll set this up. So let's just refresh what we were doing. All right, let's just see where we are right now. So does anyone have a if you guys want to post some tasks to test things with or domains, go ahead and post some stuff now. I'll use these while I'm testing stuff. All right, this is what we're gonna try this with. Specific tools or technologies. We'll remove this for now. Let's see where we're at. All right. So our module selection is decent right now. It's working slightly. I mean, it's working functionally. Absolutely. It's just we'll see when it does the second level. And you can see how it tailors the completion of this task based on the parameters, right? Like I added in timeline logic here and kind of swapped what this is a little bit with the kind of silly setup that I put in. I like to test stuff with silly setups like this though, because it's doing this in different types of ways like this is a good way to limit test some of this stuff, right? So here's the thing. Once why am I even focusing on the nodes like this? It was because this locks in everything else, right? You want this part to be done to the best degree possible. This is the gatekeeper. This is the gatekeeper of your content, right? Because this is going to structure what the lessons are, right? Because after this point, you could be like, great. Now deeply learn and synthesize. I don't know if we'll have to see this. Sometimes GPT doesn't actually like to do things. Synthesize the introduction, the first lesson. Probably gonna do a pretty bad job, being honest with you. This is GPT. Now, here's the thing. I have nothing to find about what a good lesson plan is, right? So here it's creating a lesson plan, but really all it's going to really be doing is just going to be creating an article, basically, right? It's not going to be very interactive, or it's going to be missing a lot of elements that you would have noticed in the prompt engineering lessons I shared, right? This is a result of GPT's extremely small response limit, right? There's very little that you can do in a single response with this low of a limit, right? This is nothing. All it really has time to do is just plan like the outlines of stuff, right? It can't actually generate an actual course. Like, for example, like Cloud or Gemini can do can do things 10 times as long as this in a single response, right? So they're much better for generating things compared to GPT, right? Because you can get around that, or you can attempt to by using tool chains now. That's the thing, right? But that's a separate module, okay? Let's set up the structure for what this will look like. I like to use callouts in Notion for this now. This is something I've been doing new. This is something more recent that I've been doing, because you can copy these objects directly and it works really well. Main knowledge. So each of these would ideally have a prompting logic set up in each of these. Let's find out, okay? Now, when you're modularizing like this, you learn that there's a lot of different ways that you can modularize, right? There's a couple different things that can additionally be done to modularize things further from this, right? So this can be the prompt, right? And then you can also have a couple other things, right? You can have response anchors. You can also have tool chains. Now, right now, tool chains are only really applicable with GPT setups, right? And because of that, you don't really want to have them hard-coded into solutions that are attempting to use other LLMs as well, right? I like to modularize this because of that separately, right? So you can have optional tool chains here to get things to work with GPT, and it might not even be a bad idea to do this anyway right now, just because as soon as they release something, it's going to become more viable to use again, right? It's just a matter of time. So there's a couple different ways to modularize it out. Since we've already built out something for the sequencing module, I'm going to go ahead and So we already have a couple of these things here. Let's copy this. Oh, I forgot another thing, right? We also have a template, input templates. Remember, we're actually going to be, so this is the prompt we ended with last time. So now let's modularize this a little bit, right? So this is the response template for the module selection. Okay, so we can remove that from there. This is the input template for personalization. So we can move this up here. Right, these are high level framing instructions for and bottom level reminders for it feels good where that is right now. Okay, so now we can because we modularize this, I'm going to eventually move this to bottom frame. We'll just keep it like this for now. You can see how you have a better idea now of what we've done so far, right? So this is kind of the setup. This is the meta prompt, right? This is how the meta prompt will be structured at first, right? Because and it also shows you how the different steps are that need to be working for this, right? Now, there's a lot of different things that you can do once you're at this point, right? There's a lot of different ways that you can go from this point to the next point. A lot of different ways. I'm actually going to show you a couple different things. Before we build this out more, I'm going to show you a couple different things that you can do with setups like this, right? Like, for example, let me just copy this. That's what this is right now. Let's go to cloud. Oops. I'll screw it up. Let's do this. I really like how it includes the code blocks in here as well. It's just a shame you can't manage the dialogue at all. Oh, this got screwed up. Oh, shit. All right, whatever. Huh. I mean, so this is the thing about Opus, right? It's way smarter than GPT. Like, it's not even funny. So this is a really good way to test logic too, right? Because you're going to struggle getting things to work in GPT, and that forces you to refine things to further degrees. And then when you take that to a better model, it just works, right? And even though I have not actually provided any more, I haven't even included the prompting logic or like anything else in this. It's able to follow what I'm trying to do, right? Right, literally nothing is even here. It's following exactly what I wanted it to do, right? That's because this logic is the only thing that's input, right? So when we build this out, the other parts, you can see here how flexible this is, right? Because remember what I was telling you in the very first lesson, right? When you have a strong meta prompt, right, that projects a lot of behavior, you don't even need to give it parameters. It will make ones up. It'll make things up on its own. See what happened here? I literally just pasted it with no context, completely abstracted, and it just did it on its own, right? That's how you know logic is strong, right? That's how you know that functional logic is strong here. All it really needs to be done right now for this particular part is refining the selection logic, right? There's a little bit of cleanup that could be done, but this is strong. This is strong planning logic, right? This is a strong. Let me look at this. How it's actually selected stuff. Fundamental, good. Supervised, good. Unsupervised, deep learning. Okay, this is a really good. I'm actually really impressed by this. I've generated a lot of course outlines for machine learning in general, and this is probably one of the better ones I've seen in terms of capturing everything. Transfer. Wow. Nice. Let's actually here, let's look at something. We can directly compare this with, I have a professional Where did I just put this? There it is. By Andrew. What do they do? Supervised. Deep learning. Unsupervised. Reinforcement. False ingredient. PCA. Honestly, this is a little better. This is organized more better than the one Andrew has. Okay, so anyway, our course selection logic is really good. Now let me show you something now. Because this is Opus, right? I'm not restricted to GPT's response length limits, right? Now I can be like, let me show you what you can do. I don't want to test one thing here so I don't hit my cap with this, right? Now, something I want to note when you're doing hand prompting, free prompting, whatever you want to call it, right? Is the power of concise feedback. I always consider feedback in terms of if I should give it or not and how I should say it every single follow-up, every single time. I always start with the feedback in an extremely concise manner, right? You can this is what I typically do, great job, and then I change the adjective attached to it, okay? In terms of how well it does. And then it's able to, when you do this over multiple steps, it's able to, if you say good in the next one, it'll consider that less than the great, right? It kind of sets up a feedback loop that lets you use concise feedback to determine how well it did, right? So when you give feedback, you're basically telling it that it did something right, and then it will advance upon that further, right? If you don't give feedback, sometimes it will assume it did something right just because of how the next step that you're giving it, but feedback is a really good way to fine-tune behavior when it does something right or when it does something wrong. If it does something really well, it's a really good way to give feedback to lock that in further. Okay, great job. Now let's start the generation. Awesome plan edition. Start. One. This is a bad way to do this. I'm just trying to show you the differences, and we can even use the same exact prompt that we used here. But remember, again, all we have here is the core logic for forming the nodes. We don't actually have anything established for making this personalized, making this interactive, or anything like that. Okay, so it should create a better course compared to GPT, but we'll have to see because we don't actually have anything defined. If it does anything, it's going to be emergent, right? Two. As you can see here, it's following this. This is why the node selection is important, because it's going to be following this for its sections, right? For what it actually creates. So that's actually not very good. Right, this is a very high level thing. It really doesn't have much to go off of, to be fair. Okay, anyway, we need to build out this. This shows you how we need to build out the generation module, right? All we really have, so we have, you can see the strength of the core module selection here, right? And then it breaks down immediately once you try to go to aspects of this that are not defined yet, right? So this is just a way to test stuff, and an example of how you can just paste these objects to do things, right? When this is done, you'll be able to just change these, paste in, and get it to work. Okay. All right. So what should we focus on next? There's a couple different directions that we can go towards. Let me see what you guys said real quick. Ultimate sandwich course. You know what? I'm thinking maybe I can try this. Let me try this prompt I already made in here. So for each of these, so we can give it logic that hey, response anchors tool chain. Oh, let's add input template to this as well. Okay. Tool chain response input template. Anchors tool chain. Okay. Tool chain input template. Perfect. Okay. So you could technically have stuff built out for all of these, right? And then at the end, you can have another one, right? So this gets complicated. What happens when you start putting all stuff together, right? You start providing a ton of logic. It doesn't actually know what you're trying to do, right? That's why you can add a new layer, right? So this is the core. This is like the core logic of this, right? This is the knowledge base of the prompting system, okay? But how do you actually exert control over this, right? You do this by establishing a command scheme, okay? Cool. This will be a dive on its own, but we'll start building this out today so that way you can see how this will work, right? Each of these is going to have parts of this prompt that are important, right? So we're going to start building this out, and I'm going to show you how we can start doing this. And let's copy this whole thing. Now, this size this should be small enough for GPT. Now I'm gonna paste this entire thing as the input prompt, okay? And then I'm gonna add bottom framing instructions here to abstract another layer past this and interface with this, okay, as a prompt itself. Actually, you know what? Let's test this first. Just see what happens. I like to do that sometimes. Do anything. See, now it's confusing. It doesn't know what we want to do now, right? Because we added the other thing in there, right? We added different things to do, so it doesn't know what to do now. That's GPT, though. Let's see what happens if we try this with cloud. See, it's getting really confused there. Hmm. Funny how that works. All right. And that's directly because I added in this here, right? And this was not synergized with anything else, right? We'll leave this for now. Okay, so let's look at this input template because we've modularized this, right? Some of these are actually important for different parts of this, right? So in particular, this part is not important here. This is important in the first part, domain, knowledge acquisition, right? It needs to know the domain. Actually, doesn't really need to be a title, right? I guess it could be a title. The title can be used to define the domain as well. That's fine. Audience, yep, learning objectives. So this should all be in the second one, right? Course. I don't like duration, of course. Let's change this to actually, I guess it's fine to leave in there. Okay. All right, so we have some inputs. Let's establish inputs for all these modules first. Okay, inputs here. These are good for personalizing it. Okay. Third one, sequence. So what would be important inputs? Oops, for this, for the sequencing module, right? Well, one, number of points. You can define these if you want to start exerting control over the size of the structure, right? And then for the generation, right? We're going to want, this has to be done in a step-by-step manner, right? So we're going to have course. Let's name the course to keep that anchored. Lesson. So, okay. These are basic inputs for this. Oh, no wonder that wasn't working because that's prompt was, I put that in the wrong one. This one is supposed to be in this one. It's supposed to be here. Yep. Okay. Okay. So now I have some inputs for all of these. Now let's build some basic commands. Let's name. Let's do something else here real quick. Let's add a master top framing instructions. I need to think of a better name for this. This is too restrictive of a name. Lesson plan, personalized learning engine. And this is where you can kind of add some high level framing, kind of like if you remember the Anthropic meta prompt here. right? They have a top framing section that outlines the entire system on a higher level way from the start, right? And then they go directly into shots. So the shots part is something else that I want to talk about here. We're not going to be doing that in this stream, but it's a really good way to fine tune the behavior of different modules when we're at that part. Okay, so you can add kind of high level framing up here. Right now, we're just going to keep it as placeholders. We always call it placeholder. So that way the AI understands. Nice one. So now, because we called it UPLE, all right, we're going to anchor this in with the command ultimate. Oops, that's personalized learning. That's what. All right, so we're going to establish a function. Okay, that kind of ties into other things at the same time. And if you've used my GPTs before, you've seen this kind of functional logic before, right? I like to use stuff like this to develop control schemes to actually start controlling this stuff, right? So you can set up a core base right here for the command, right? And then now you can actually start defining things, right? And we can do this for each different thing. What this will do is this will functionalize this in a sense. Let's do this for the basic thing right now. Main knowledge acquisition. Oops. Sequencing. And then learning objective personalization. This is just a basic, super basic way to do this. Okay, this is just attempting to establish some low level logic for these parts. Okay, so now let's try this again. This isn't actually what I'm doing. I'm just testing the logic here when I do this. Yep, it's fine. So I'll show you here in a second what you can do. Let's try this again here. See, it has a better idea now with the system, right? Because I've provided more measurements of it. See, Klein is exactly what we're doing here, right? Okay, so this is just the very base interface, right? So again, just need to add bottom instructions. Okay, so let's start co-create design. Oh, I hate when this happens. Okay, we are developing and one prompt engine. Well, All right, so by adding bottom framing instructions. All right, see you, Jimmy. Have a good night, man. Adding bottom framing instructions allows you to easily interface with a complex, prompt just like that. See how it's working with GPT now just because I did that? Wow, look at that. It's actually populating each one for me. Look at that. Okay, so now GPT has been quote unquote trained on what we have so far, right? So it has a decent idea of what we're trying to do here. Okay, so because of this, now I can start interfacing with different parts, right? So reflect on and I can actually hard call certain sections of this, right? I can be like reflect on here. I can make my own meta template for designing this, right? Now I can set up a couple things, right? So I'm going to define for new LPE just to anchor in what we're doing. Rule 1. Emphasize. Find. What do we want to try first? We can do the refined input template. I don't know. Here, this is where you're going to start. Now we're going to start probing. We're going to start seeing what it determines are some crucial inputs for different parts, right? Just to try to see. There you go. Now here's the thing. This is like an ideal. This is like an ideal. Like no one's gonna want to actually fill this out half the time. That's the thing. But it's still useful to build these out because even if you only once we're finished with a solution, even if you only wind up going with some of them, or if only some of them are filled out, the rest of these provide the structure provides context on other things that are important, and then it can kind of fill it out for the user. Okay, so I like this. This is actually pretty decent, but it also is clipping some stuff. We'll have to test this. We'll have to see what the best way to handle the domain knowledge acquisition is. We're probably going to need to create an SPR flow just to create maybe just step one is self-discover a knowledge structure for the given inputs. I just don't know if you want to restrict this much first. Let me look at this again. So we have this one's better in general, just because we'll just use this for now. We'll use this for now. It covers more stuff. Okay. skip that. Now let's try. Let's see what happens here. This is once you have a structure set up like this is how you can start leveraging holographic interconnectivity to start co-creation of the other parts. Okay, because based on whatever you already have defined, it's going to be projecting from that to try to do something similar but in a unique way for different things. Right? What this does. Nice. That's actually pretty decent. What this does is actually no, I don't like that, but. Yeah, see, it's doing this because it came up with too many. And this is why this is an iterative process, right? Because if it's you can also see how just the structure that I provided in the initial prompt is just is being protected and different things it's doing with the syntax that it's deciding to use, right? I'm not even telling it to do this in this particular prompt, but it's doing it automatically. I want to try something else. Let's try this now. Let's try having it do this first without having improved the input template first. Oh, look at that. Ooh, that's really good. This is a really good response. Ooh. Ooh, look at that. Look at that. See, this is the beauty of emergence and working with emergence, that you can find better structures by doing this. So this is a really good way to do that, actually. See, sometimes you just get good stuff with GPT still. It's just you have to start mixing up some logic. Okay, so this is really, really, really good. Now this, I'm not actually going, Ideally, you don't, for this kind of stuff, you don't want to provide a shot. Like I would not want to actually provide a shot for but I really like how they have I like how they have the key, the prerequisite with the learning objective and description is the way they form this is really, really, really nice. This is a semantic progression almost. Self-discovering the progression of learning. This is really, 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 this is perfect for what the domain knowledge step would need to be. All right, so I'm going to copy all of this actually, and we're going to save this because that was really good. Small device this a little bit more. So we'll put all of this into the usage category. Usage, output, specifications. It's always, whenever you're doing complex stuff, it's always really good to. This is kind of the response anchor almost, in a sense. We'll tie this in together. Okay, this is an input. We already have this mapped, or we already should. I guess I erased it. I'm gonna remove this. All right, and this is the main prompt, right? Purpose and the task, right? And then we define the task through the shot and the output specification, right? We don't actually give deeper instructions compared to that, right? So this now is a pretty solid prompt for module 1, right? And we didn't even do anything yet. This is just this is a synthesized structure, right? We're going to be refining this, but this gives us a base to work with, right? And we're going to be generalizing this logic, this key structure here, without using an explicit shot, because that'll truly generalize this part of it, right? But for now, we're gonna use this because this is a good way to start off. Okay. Let's see what happens now. I want to see, because here's the thing: my response anchors like this are very, very, very unique and are extremely compressed. And typically, it's difficult to get the AI to actually replicate this correctly, especially with GPT. The other ones can do it well, but GPT struggles with it. I want to see what actually happens if it will give me a response anchor like this, or if it'll mess it up. It'll probably mess it up if I had to guess, but we'll try. And right, here's another thing. You can really just do this at this point. Copy this. Add some feedback. And it'll say great job. Let's see what it does. Yeah, it's screwed up. It doesn't understand. It doesn't understand what a response anchor is, right? Because I don't actually have it defined. Right. So let's try this now. Let's add some context. Response anchors are hyperconstants. Anchors for the elements that frame the hive. Now, here's the thing: when you when you try to get it to work with response anchors, and I also forgot to close the. It's fine. When you actually it screws up the syntax, right? What is it doing here? Oh wait, shit. Oops. Huh. So this just this just emerged something in a completely different way. But I'm already aware of this happening. So okay, so this created a higher order response anchor, just like that. Okay. This really isn't a response anchor, but this is very valuable. We can just, I don't know what to do with this right now. Actually, you know what? As I'm thinking about it, this might actually be the ideal response structure for this type, because this will abstract it. This is basic. If we can generalize, if we can use the shot without, because you can use shots like this if without crippling performance if you abstract it to a further degree, which this might actually do. Okay, so since this happened emergently, this is something just like I want to save this, right? Because this is if I were to refresh this, this definitely wouldn't happen again, right? Like that's just us. Oh, it is doing it again. Wow. This is this is the problem with so literally I just have to include a single measurement of a different prompting system that I had that I made this prompt with, and it's projecting it on its own already. That's crazy. I was not expecting this. Okay, anyway, that's fine. This might even be an even better one. Yeah, this one's even better. This one uses the other elements. Yeah. All right, so let's go with this one then. Okay, so since it did this, right? We technically could do something similar for each of these modules. So now it could be like, move this. Oh, I said module 2. That's why. It was actually module 3 that I have. Oh, interesting. I made a mistake there, but the mistake was beneficial in this case. Actually, you know what? This is what we'll do to leverage this because this isn't really this is like a high level. We can change. We can. This is like an algorithm almost. This is like a what would be the best way to call this? Process. Right. And we can put this. Might want to put this below the input. And now we can put it above. Okay. So now we have a pretty beast first step now. We haven't even tested it yet, but we already know it's gonna be good. I want to add this process step to all of these because this is the kind of stuff that you want to see. That's high quality logic right there. We could probably erase. There's a lot of instructions. We could probably erase a lot of those. Okay, process. No, we already have process here. That's pretty much all of these together. Process here. Okay. All right. So I screwed up on accident, but we're gonna reverse this so that way this is beneficial. Interesting. I didn't have anything in it, so it used the fourth because it had nothing to go with. Okay. Okay. Interesting. So let's try this now. Module 2. Let's just see what it does. Let's have it map all of these. Nice, 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 nice. I like that a lot. I like that a lot. Perfect. And this is the benefit. This is a direct benefit of modularizing this. This is what directly allows this to happen. Okay. And also it allows the emergence to happen to this degree. Let's do the next one now. Let's just go ahead and synthesize it for all of them. 3. And now this one has a lot of context to go off of for this one. So this one should be pretty decent. Yep, it already knows what to do with the core. Exactly. Perfect, 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 perfect. Oh, this was the best. This was actually amazing news for the solution. We can definitely realize this now. I might delete these instructions. It's so much instructions. What we can actually do here is, I have an idea. Let's get the core logic here. So you see how I'm just copying, pasting an exact template and just changing the input to synthesize this uniquely for each step? This is something I leverage a lot. Content detailing, methodology, design. This is very different. Try this. Yep, okay, that's good. So we have core algorithmic logic now for each module that's synthesized with symbolic logic. I'm gonna have to I cheated a little bit here by using my other prompt. I didn't realize this, but this is the problem with doing this, is that these patterns propagate. I'll have to do more dives into the future on how this symbolic logic is working. But in the meantime, just it's mapping steps to symbols, and then it has a lot of different effects as a result. It's just a basic to understand here. But it's really all this is really doing is providing a high level understanding of the process for each step. Okay. Let me make sure I don't have the response structure copied in any of this. Yeah, I want to remove this because it's not actually a response anchor. Remove this. This is data cleaning, right? You're removing the information that's wrong. Okay. So now, I mean, I want to save this because this was really, it's not really a response anchor though. So this isn't really what it is. So what I could do is I could just redo this from this new understanding, right? New base. I actually want to do exactly what I did before. Really, let's do this. Let's keep the same one. I really want to keep this logic. This is really strong. I hope this fits. It should. You know what? Let's go ahead and add. Here's another thing. Adding versioning logic is extremely important. It allows the AI to delineate between versions of structures like this. So we'll go ahead and add in some versioning logic here. Okay. Let's keep this. New version of the U. Let's keep it open. All right. So now by doing this, I'm updating its knowledge based on the refined structure that I made based on the things that it has done. And I'm also changing its understanding of what these are, forcing a new version. So if this does it right, I should be able to, it should update this correctly and then be able to assist to further degrees in co-creative design after this. Okay. We'll see what happens. Here's the thing. I mean, you don't even really need you don't even really need prompts in the normal sense at this point. Really, the prompts are just going to be high level framing, right? Because the logic is mostly functionalized at this. See, it understands everything very well at this point. Right? This engine is operationalizing as we build it at this point, right? So now it has a much better. Remember, I had it learn. I didn't actually tell it to do anything here. I just had it learn the new version without a task, right? And what that does is that it has it learn everything at full complexity. Now, if I do more specific tasks after this point, and specifically anchor it to version 1, it's going to advance upon everything to do this. See you, VL. No problem. Thanks for coming. Only going a little bit longer. I know it's a weird time today anyway. No worries. We'll have the video up at some point. Okay, so we have really strong knowledge here now, right? So now we can start working with other sections, right? So let's look at what we have right now. Great. Now we enter in module 3 and then 0. Let's go back up here and find some instructions to borrow. Now we're going to add in the one thing I'm going to add in the version number here because it's going to anchor in everything to be projected through the new version. Okay, if you don't do this, sometimes it can get confused with the different versions, and this is a good way to just completely avoid that. Okay, so now I want to test this. I want to see if it's actually able to make a proper response anchor now. Under 1, and we can just remove the name now at this point. Response anchor. MD. Let's try this. And you see how I'm modularizing my own prompts as I'm doing this co-design? I do this for everything, right? Because it just streamlines things. It's still doing it. All right, so we need to provide, so it's screwing up, right? So we need to provide an explicit shot, right? Oh, it's because I have it plural. Oops. Doesn't help. Also don't have one. Oh, I don't even, oh, damn it. I don't even have one in here. I messed up. Let's change this to MD. I think that's the move here to delineate this. MD. Oh, that's what we'll do. We'll also change these to mermaid as well. Mermaid. Mermaid. We need to add a prompt for this. Most of the work is setting up the structure. That's just the reality, right? Because when I'm labeling things over several layers right now, right? And this is continually improving its understanding of everything. Prompt. See if everything else has that. Prompt, process input, output, usage, response anchor. Ideally, I want to copy this structure to everything else. Response anchor. MD, mermaid, code, mermaid. B. A. Perfect. MD, mermaid. Okay, perfect. Ideally, we want to change this to specs. Okay. Should be solid now. Now this is a very solid structure, I will say. Missing usage. I don't know if I actually want. Usage is this is gonna be converted into shots. Like I'm not really gonna be using this usage how it is right here. I don't like providing explicit examples of knowledge structure. I think it impacts the downscale task too much. We'll do this in the next part though. For now, this is fine. In general, this structure is very solid right now. I'm going to refresh its understanding. I'm going to redo the learning step with the new structure, so that way this can be done better. Okay, I'm just going to replace everything here. The updated one. Should get better results. Okay. Now let's try the this prompt again now. Now it has a delineated section for this. I'm going to anchor it with MD. We'll see if this works. Hopefully this works. I might need a hard define. No, not symbolically. Damn it. Actually, That's not what I want, though. It's fine. It doesn't know how to do response anchors yet. It's okay. I could provide a high level. I could provide a shop. I don't want to do that right now. Let's instead. Let's just flesh out the prompt. Let's do this. Prompt. Module 2. Prompt. Perfect. Now I can just run this for the other two modules and we'll have a good base. And then next stream, we can integrate tool chains, have this functionalized and working on every single LLM, just like that. Perfect. Okay. We'll delineate that in a second. Now let's have it generate the other ones. We don't need any of that. Output. Oh, now we need the, of course. Yeah, so usage is going to get warped into shots, but that will be done next week. Is this generating? Okay, good. Output. I already have that. Usage. Okay. Now we can delete all this. Yep, it's doing everything perfectly. Now let's have it do the last one. Module 4. I already put a prompt there. Okay. No. Awesome. This is starting to look really solid. Oops. Last one. Perfect. Output. Usage. There we go. We're looking solid now. So now basically the core logic of this is set up now. Core logic. It just needs to be shaped. That's it. Okay. And we shape this with response anchors and tool chains and instructions. Okay. Tie that all in with commands. This is a super solid base that we have been able to establish here. Now I'm probing for some better high level framing instructions based on this updated understanding. We'll see I'll just see what it gives. This is awesome. This is turning out really good. Or something else that I did not too long ago. Let's do this. Capture some high level information. And here, up here, we can go and be like, have the same ones: title, description. Okay. Oh, I did that twice. Okay, so now let's see what it did. Yep, that's good. Has the acronym locked in. Perfect. We can bold this. That's pretty long. It's fine. How fast this is coming together. Aims a personalized education at scale. Absolutely. Yeah. I like to add in these as much as possible to delineate things. Okay. Okay. Look at that. All right, we have a pretty nice prompt here right now. It's not functionalized yet. I mean, it's functionalized when I add these. When we add these anchors, it's functionalized. And then we just got to start refining it out. I'm really happy with how this has turned out. Let's just do a little. Let's see what it does here. It might not do this very well. Yeah, it's fine. In this one, we don't really like this would be more of if we were the command structures in this solution is going to be kind of hard coded just because the point is to streamline the control. We don't want to extend. I mean, we can build extension command schemes that allow like further degrees of control, but the core focus for this will be wow, I mean that's pretty damn good. Yeah, that's pretty damn good. I want to do a test real quick. Let's see what happens first when I just enter this, and then I want to try entering it with a bottom frame instruction. Oh, cloud. Oh, cloud. Oh, cloud. This is the one con of cloud right now. Sometimes it just refuses to do stuff for absolutely no reason. So in this case, it doesn't want to do it because it doesn't have a perfect context, meaning we didn't actually provide it with what to do. So now let me this is so dumb. Let's do this. Let's test this. Okay, so we'll start with where am I right now? Over here. What was the thing that creating the ultimate sandwich? Creating the ultimate sandwich. Let's do that. We can even do, I'll have to clean this part up, but we can do. Actually, no. I don't know why I did that. Just keep it like that. Hey Snoop, I'm about to be finishing up here, but you're catching the last end of this. Okay, there we go. Oh, perfect. And it's doing if as long as it doesn't stop at 3 sections, we're in a good spot. If it's up to 3 sections, that means that okay, good. Oh, this is perfect. It's advancing upon it. Okay, wow, this is turning out even better than I thought it would. That's actually perfect. It's not restricting itself to the previous structure. And this is literally just like the most random subject ever. Execute different cuts for visual impact. This is the best sandwich making guide you've ever seen in your life. Holy shit, this thing is not messing around. Damn. Okay, so we have a really this is okay. So the first step has turned out way better than I thought we were going to be able to do today. Wow. So then, yeah, I guess in that case, then we don't really. I mean, you can use simpler inputs like this. What was the next thing? Define objectives. Okay, so we need to name the course again. This was creating the ultimate sandwich. Who, now we need to define See, this is a good job here. Like we don't actually want to define key topics. We want to leave it open-ended. Let's go back to this input template because we can mix this up a little bit. We really only, it already created learning objectives. So I honestly, because of how strong it was, we can just give it some very minimal input. Ideally here, when this is built out, this will be, the template will be better to customize things at this point. I have to refine this part, but we'll do new chefs, new sandwich chefs. Chefs. We're gonna fix the syntax here. New sandwich chefs. What else should I say? What's another important factor? Mastering sandwich creation. I don't know. All right, so now it should move to module 2. It's also quiet reflecting, even though just keep this in mind, right? I don't even have a response anchor set for this, right? But the only response anchor I've set is here, right? So it picked up the quiet reflection from this, but then did a different task. Where is it? It did a different task. See, it actually did this perfectly and picked up the response anchor from a different part correctly and did the task correctly, right? This is what I'm trying to get here with. Like when you modularize things like this is what starts happening automatically, right? Let's see what happens now if it does the second part. I haven't actually tested it past this part yet, so. Look at that. Okay, and it's coming. Oh, this is exactly what I was talking about. It's using the other fields to personalize it further. This is perfect. Wow. I mean, I need to remove the thing is I don't want logic in here making it think that it can make videos and stuff like that. It confuses it, right? We're not there yet. But this is outside of that. This is wow, this is really good. What was the other one? Course structure. Oh, perfect. And then we can just at this point you can just immediately you can narrow it in simply with the this is actually turning out way better than I thought it would. Wow. Okay, so we can select the module creation. So now we can do 5 and 4. So this should create a 20 plan. This should create a 20 lesson course for creating the ultimate sandwich with 5 main modules and 4 sub lessons between each of the 5 main modules. So 20 lessons total split between 5 core modules. That's what we should, when I enter this, we should get a response that gives the first level and second level following these parameters, building upon everything else, and everything's being done automatically from the meta prompt. Okay, this is my first time testing this. This is the power of doing it. You can build knowing it'll work, right? Perfect, 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 perfect. I did for each, perfect, perfect, perfect. Look at that. All right, so everything, okay, all this, awesome, awesome. So if you look here, we now have, oops. These are done. These are very solid now. Now all we have to do is build the generating thing, which is already mostly built, and anchor this so that way, because like here's the thing, this already is functional on Cloud Opus dialog system, right? That's because this is the most intelligent and best platform there is right now. If once you have stuff structured this way, if in order to get this working to this degree on other platforms or other models, you have to start doing more, right? Let's just test it. I don't think this is actually going to make the best. I could be wrong. We can do ultimate sandwich. And now we can do, let's test this. Sandwich making fundamentals. We're going to include the number. This is basically creating like a textbook at this point, right? All right. Bread selection and preparation. So anyway, hopefully we have some expert sandwich makers so we can verify this. I had a sandwich yesterday. Maybe that's enough. Yeah, it's still very high level still, right? I need to refine out the logic for the generation. That's the last part, right? We have the engine going now. Now all we have to do is functionalize the synthesis. I could probably do that, honestly, by doing this. Great. Now actually synthesize the content for this lesson plan. We'll see if it does it better in this one. I think I need to tweak out. This is the problem with the teaching methods. You can't have it think there's too many, because then it starts becoming abstracted instead of actually generating the content, right? So now it's actually generating the content here because I did this. So really what we want to do is we want to take this functional logic, put it in here. That way it does it automatically from the start, okay? So if I wanted to now, because I updated its understanding of what it's supposed to be actually doing for the synthesis of the generation, right? Now I could literally just go lesson by lesson and synthesize this entire thing, right? And it would continually build upon everything in the past, right? This is now a working engine. It just now needs to be further functionalized and refined, right? And the entire prompt is right here. In the Notion for you to experiment with. And next stream we'll do a couple things. We will actually go into the tool chains, and I want to go through functionalizing this on every single LLM. Okay, we're going to functionalize this on GPT using tool chains. We're going to functionalize this on 1.5 using a different setup, and we're going to functionalize this on cloud. Well, we already did, but we're going to functionalize even more in cloud. Okay, and then we'll have, once that's done, the meta prop will be extremely refined. And then it's just simply a matter of refining this, distilling this, compressing this further, and then building out. Ideally, we can build out some API-based solutions with this to start streamlining this a little bit further, right? That's the end game for this. But this has been, I'm actually pretty pleased with how this went. I was able to show a lot of different stuff here. And if you actually watch the whole video, you'll have a good idea of how to set this up for a lot of stuff. That's going to be the end of the content for this stream, though. Okay. We will pick back up on the next stream to finish this up. Snoopy, did you or anyone else? Do you have any questions? Anything you want me to discuss before we end the stream today? I'll have the video up later today. Okay, no problem. Thanks, Snoopy. I think you'll like this. I think you'll like this video a lot when I have it up. We'll do some cool stuff today. All right. Well, catch you guys next time. Thanks. Good night.